Okay, let's take a look at a second method of solving for our quadratic functions. This is the square root method, and here are a few indications of when to use the square root method. I especially want you to know that using the square root method comes into play when you do not have your linear term. So let's just take a look at some examples. Now remember, we're solving for x. So I'm going to use the square root method here because I don't have my linear term. I'm simply solving for x. So I'm going to simply undo squaring by taking the square root, but I'm going to remember that when I take the square root, I need to take the positive and negative root. So my two solutions are positive and negative 11. You could write these as negative 11, comma, positive 11, or as you see here. Here we're going to take the square root of both sides. We're going to remember to take the positive and negative root. So our two solutions where this quadratic function crosses the x-axis at positive and negative 14. Again, I have no linear term in this equation. My two roots for number 3 is negative 10 and positive 10. Now let's take a look at number 4. When I take the square root and the radicand is negative, I'm going to have no real solutions. We cannot have a negative radicand. So your answer is no real solutions. This means this quadratic turned up and it did not touch the x-axis at all. There are no real solutions. Let's do these. I can't simply just take the square root yet. We are solving for x, so we need to divide by negative 3. Here, we're going to get a positive 16. We're going to take the square root of both sides. Remember to take the positive and negative root. So my two solutions are positive and negative 4. Number 6, we first need to divide by the understood negative 1. We're going to take the square root of both sides. And our two solutions are our two zeros are positive and negative 9. Here, and again, in all of these examples, we have no linear term. We're going to add 5 to both sides. We're simply just solving a one variable equation. Undo squaring by taking the square root, and our two solutions are positive and negative 10. Solve for x. Undo squaring by taking the square root, and our two solutions are positive and negative 7. Let's take a look at two more examples of using the square root method. Notice that this binomial is squared. So to solve for x, we first have to undo the squaring. So I'm going to take the square root of both sides. This one's going to be a little bit different than the other ones we just looked at. We have 2x minus 4. Remember, taking the square root undoes squaring. So now I just have 2x minus 4 equals positive and negative 12. Now, unlike on the other ones, because we still have to get rid of the subtract 4 and the multiplying by 2, I have to set 2x minus 4 equal to negative 12, and I have to set it equal to positive 12. I have to solve these independently, individually. Now we're going to add 4. This is going to give us -8. Divide by 2. And we have a solution of -4. We're going to solve this equation. Divide by 2. And the other solution is 8. So when you have a problem like this, don't just think the answer is going to be the positive and the negative of that number. You must write the equations separately. Make sure that you do this. I have to write this equation, set it equal to -12, and then set that expression equal to +12. Okay, let's do number 10. We're solving for x. In order to get inside the parentheses, I must undo the squaring. To undo squaring, we take the square root. When we take the square root of an integer, we must take the positive and negative root. Taking the square root undoes the squaring, so I'd simply have 3x plus 1 equals, I'm just going to go ahead and write this as 2 equations, -15 and 3x plus 1 equals +15. 2 separate equations. Subtract. This is going to give us -16. Divide by 3. And we have x equals -16 over 3. And we can leave it just like this. If we were to try to estimate and graph it, then we could turn it into a mixed number. So here are our 2 solutions, the 2 x-intercepts. So please make sure when you come across examples like number 9 and number 10 that you write your 2 equations separately, setting one equal to the negative root and the other set equal to the positive root.